I'll make my introduction to this panel brief, but I do find it interesting that this is an all-Illinois panel. Each of our speakers is from Illinois, either northern, well, I guess it's northern and central Illinois. As David said, this kickoff panel is focused on the relationship of arts programs and interventions to psychosocial function, to behavioral or cognitive function, and there'll even be more than a modicum of neuroscience here. I really think of this symposium and the review that'll take place is Clint Eastwood has been in the news recently. I promise none of us will be talking to an empty chair, but I do think of it as the good, bad, and the ugly. The research in this field is quite interesting. There are some real gaps, and that's what this workshop and symposium is about, and those are the kinds of things that will be discussed and reviewed, both in this symposium and others. Our speakers for today include the dynamic duo who are sitting in the front, Tony and Helga Noice. Tony is a professor of theater, and Helga a professor of psychology at Elmhurst College, which is our northern Illinois contributors up around Chicago. And they'll be giving both a broad overview of the arts, cognition, and psychosocial function with a focus on theater and the work that they've done over the years. Our next speaker will be Nina Kraus, and Nina's a professor of neurobiology and physiology, also in northern Illinois. And her focus will be mostly on music, both neuroscience and behavioral measures. We'll start off with the two 30-minute presentations and then follow with a 15-minute open discussion, which we invite all of you to participate in. Tony and Helga, the floor is yours.
Okay. Thank you very much. Where is the clicker to advance the slides? Is it over here? Yes, that should do it. Okay, we're here to talk about participatory arts. That is not enjoying and viewing arts, but doing and making arts. That's the whole idea. And this doesn't seem to be advancing slides. We have our top technical person here, or even a we'll accept a third assistant technical person.
I don't know. Well, I guess I wasn't qualified to do this.
You weren't the third assistant, darling. While we're waiting for this, I would love to disagree with my friend David Rubin about one thing. He said there are no side effects to the arts. Unfortunately, if you're talking about full-time professionals, there is a side effect. It's called poverty. Oh, it's working now, or you're just doing it from there? Well, let's see. I'll go back. No, this still isn't working, so you'll be able to do it. Terrific. So our particular specialty is theater. Oh, you've got another one. Thank you. God bless you, darling. So our particular specialty is theater, particularly acting. And why is acting beneficial? Well, it's multimodal. It's cognitive, the thoughts the character thinks. It's emotional, the feelings. Physiological, because thoughts and feelings inevitably lead to different body language, tone of voice, facial expression. And it's highly activating because everybody has to get up and do it in front of the others. There is no participants. Everybody's active. It's also novel, which is one of the hallmarks of effective interventions, something that people haven't done before. Few people are crazy enough to be actors. We've never had one in one of our studies who had been an actor, not even an amateur actor. And it also engenders very strong social support in as much as everybody knows they're going to be up there doing the same thing in just a minute. And so they're all pulling for one another. It's a terrific thing to watch. So one of the criticisms that has been labeled, and pardon me, I'm just getting over the first bout in my life of bronchitis. One of the criticisms that has been labeled with the reports we do is that they're wonderful for giving methodology, for giving statistics, tons of statistics, charts, and tables, but they don't really show you what we're actually doing. So I'm going to take the first 8 or 10 minutes to actually demonstrate what we do when we give this intervention. And the first thing, and you have to help with this, you have to be an acting class, because if you don't, this means nothing. Acting is not something you think about, it's something you do. So everybody here, please listen for every sound you can hear in this room. Listen intently for every sound. Congratulations, you just passed the audition. You're now all actors, because that is what actors do. Give an actor a script that calls for listening. He does not try to look and sound like he's listening. Only the world's worst actor. No, he listens for real. But unless the play happens to be taking place at the National Academy of Science, we also do it under imaginary circumstances. So we'll add the imaginary circumstances. What are we going to do? You're visiting a friend's house. He or she lives in a high-rise, 10th floor with a noisy elevator. So you always know when somebody is coming up and down. She says, pardon me, I've got to go down to the car for a minute. And so she leaves you. You hear that little beep from her computer in the corner, meaning a message is coming in. So you decide you're going to take a look. So you decide to snoop. I didn't know she knew her. And you're going through her email, but all the time you're listening for that elevator. Now remember, the circumstances are always imaginary. You are not crazy. You don't think you're Hamlet. You know who you are, but that's just in the imagination. But what the character is really doing, you do that for real. So now, everybody picture that. You're in that situation. You're in front of somebody's computer. Don't pretend. Don't pantomime. Just imagine that, but really listen for the sound of a noisy elevator out there, meaning your friend is coming. Get the hell out of there and back to this couch so you won't be caught snooping, okay? Everybody try that. Very good. See, it's no more difficult than the first one. So, go on to the third demonstration. Let me advance the slides of 4 core principles. That was the first one, the reality of doing under imaginary circumstances. Third principle, you must always have a goal. Absolutely, every dramatic scene has a goal. And, of course, it has an obstacle, because if the goal were easy to accomplish, there would be no drama. So, we're going to give you a goal. Everybody stand up, please. And put down whatever you have. You're going to need both your arms. Once again, if you just say, well, I'll go along with what he's doing, you will not understand what we're talking about. You've got to really be actively involved. This is the situation, the imaginary one. You're in front of a cupboard, a closet, there's shelves, and on the top shelf is something you need. Maybe it's notes for a meeting. On the other hand, it might be a box of Godiva chocolates. I don't care, whatever it is, you really want, it's just beyond your reach. The task is, under those imaginary circumstances, to really, physically, actually reach to get it. Don't pretend. Really try to get higher than you've ever gotten before. If anybody has a bad back, don't do this, though. No accidents, please. We just want you to get as high as you possibly. But no, really try. Stretch higher than you've ever higher. Come on, than you've ever stretched before. Don't play. Oh, thank you. Have a seat. Okay. And the fourth one, that's the goal and the obstacle. The fourth one, it must be spontaneous. Acting is not something you work up at home and bring in. It must be happening right now. So let's say you and I are doing a scene. We're playing rival politicians. I have demanded, would you stand up for a minute, please? Hi, it's Chris?
Yes.
Hi, Chris, Tony.
Hi.
We're playing rival politicians. I have demanded that you release your income tax, and you won't do it. The reality of doing, friends, you know. So, we're in the middle of the scene, and my job, I say yes, I'm demanding you release them, and you say no.
Okay.
However, you have to take your no off my yes, but you have no time to analyze. It must be spontaneous. So whatever you hear, you take in, and you instinctively react to it by saying no.
Okay.
Okay, ready? Yes.
No.
Yes.
No.
Yes.
No.
That's acting. That's acting. Doing it for real under imaginary circumstances. But now, it's always now. There's always someone. We have an early scene in the first day where a man is fighting with his wife, or a woman's fighting with her husband. And invariably, this will happen. A man will do something like, "You can't do that." We say, "Wait, Sorry. Nobody's going to believe that. You're not doing it. And the person will insist and say, but that's how I fight when I fight with my wife. And you say, that's the problem with it. You are showing us how you fight. We don't want you to show us that. We want to see you fight right now. And he says, yes. She said, there she is. What are you when you're fighting with somebody? Yeah, you want to make her feel bad. You want to get back at her. So use these words to get back at her. And you coach him and you push him. Finally, he starts yelling and you say, that's it. You're doing it. And that wonderful smile comes over the face. Oh, I get it. It's not pretend. I got to do it now. Yes, stage time is always now. And by the end of the first session, almost everybody gets it. We're going to have 8 sessions of serious arts training. We are not going to have a fun and games thing. This is it. And of course, it gets more complicated as it goes along. And there's always 2 stages. The first, you got to find out what the character is doing by analyzing the script. And the second is what we were just talking about, that being in the moment. It's happening now, not something you worked up at home. And of course, they get progressively more complex because by the end, by the 6th, 7th, and 8th session, they've got to do all of this, but they have memorized scripts. And they must make the memorized scripts just as real as the early exercises. So you and I are really arguing, but you know every word you're going to say and every move you're going to make, because playwrights have a union like we actors do. And they say the producer must fire an actor who's paraphrasing the lines. They have that in their contract. So you've got to do all of this stuff from long-term memory, but you've got to make it real now, this second. You've got to do it. You can't act it. And basically, that's why we think it's so effective. And we've done a number of what we call RCTs, randomized controlled trials, with this using strict scientific methods. And we give the same acting class all the time. We've been doing this for over 15 years. Same acting class, but with different populations, young, old, people in assisted living facilities, people in upscale retirement homes and so forth. Different controls. Every time we do it, we have new control groups to rule out other things. We have compared it to visual arts, art appreciation, to see if just another stimulating activity would do it. Didn't work as well as acting. Then we tried to say, maybe it's the performance. So we tried a course in singing. Didn't do as well as acting. We keep trying different control groups with every experiment to just understand all the parameters. And we use different measures. Started with just recall and recognition. That's all we were doing. Now we're up to over a dozen different measures that we use. 8 cognitive ones, quality of life, and so forth. And we vary the teachers, too. So I'm not always the one who's doing it. We have other people we've engaged to do this. And we're now, since we'd love to think everybody here read every one of our papers, we know it's not true, so Helga will run you through a typical study.
Okay, we normally make arrangements with retirement homes or with senior centers to give a talk to their residents and discuss our study. And those who are interested then fill out a form, and we contact them by phone and administer the short Pfeiffer screening test for dementia. And those who are then eligible get randomly assigned to one of 3 groups. Now here I'm showing theater, alternative art, let's pretend that this was music, and a waiting list control. At that point, everybody gets a test. And as Tony said, those would be various cognitive measures and also various subjective measures and some questionnaires. At that point, then, our 4-week, 8-session intervention starts. So we meet twice a week for an hour and 15 minutes. We include a coffee break to encourage socialization. And then 4 weeks later, a post-test is administered, and at that point, the waiting list control, as a courtesy, gets the theater intervention. And the next slide.
Okay, sir.
Okay, I'll show you the results of a recently completed experiment. In this particular experiment, our acting group improved significantly on 7 of the 8 cognitive measures. Not only did it improve against the no treatment control, but it also improved against the singing group. However, even though the singing group had not shown any improvement in terms of cognitive measures, when we administered RIF's quality of life, particularly the growth scale, both groups, including the singing group, showed that they indeed had some improvement. There was a significant increase in their feeling of having experienced some personal growth. And this leads me to the current study. And in this particular study, our research question was, can we demonstrate changes in brain function in an active experiencing? That's what Tony was demonstrating, acting group compared to an about theater. So both of them experienced theater, but one actively doing it, the other one hearing about theater, because possibly it's the topic of theater that is so stimulating. And to tell you about the rationale for the design and some of the predictions, I'll bring up Art Kramer, who not only is our moderator, collaborator, but also our expert in imaging. And so here's Art.
Just very briefly, what we're doing here is capitalizing on about a decade's worth of research at the University of Illinois and throughout the world, using neuroimaging measures to augment the psychosocial and behavioral cognitive measures that we can use to examine any change, whatever the intervention is. And that's Olga Kokoho. She's from Saskatchewan. Olga is 93 years of age. Thanks. And holds 23 world records in track and field. Now, we never get, a lot of our work in the past has been done on physical activity. Olga has come and visited us recently, but we've never gotten any of our folks, even in a year-long intervention, to achieve what Olga does. She also does the hammer throw in addition to the triple jump, long jump, pretty much all of the sprints. I was a pole vaulter when I was a young man. She visited us about 2 weeks ago. She's even a pole vaulter. I couldn't believe it, 93. I couldn't be a pole vaulter at 59, that's for sure. But what I show here, just very briefly, are changes in brain structure in the hippocampus as a function of exercise. And those little bar graphs indicate changes in functional connectivity among different units in a functional network, brain network. Next slide, please. But we've also in the past done interventions that don't involve tremendous amounts of physical activity, and hence perhaps the application to theater, not running and jumping. This is a program that we collaborated with our colleagues at Johns Hopkins, Michelle Carlson, Linda Freed, now at Columbia, George Reebok, called Experience Core. And this is really an interesting project that takes older folks who don't have high SES, haven't gotten a lot of education, don't have good health care in the United States, and gets them involved in the community through providing literacy, numeracy, behavioral management, and library support for children in K through 3 in the inner city Baltimore schools. We've been involved in some of the brain imaging, examining changes in brain structure and function, and how they lead to enhanced memory, decision-making, and attention. So there is now a good corpus of data that suggests the possibility of using these pretty non-invasive functional and structural brain measures to augment what Tony and Helga have learned from the behavioral and psychosocial measures, and that's what we're doing in the present study. Back to you.
Okay. Terrific. I have my own, thank you. All right, they did ask us to investigate not just our field, but all the other participatory arts, and you'll find that in a paper that will be posted shortly after this. But we looked at dance, music, visual art, expressive writing, and there have been studies done on all of them, more on therapy, but studies done on all of them, and but relatively few. We certainly need more, and particularly we'd love to get more that have a real scientific foundation of a randomized controlled trial where you can really compare one to the other, as we do with all ours and as Art is now doing because he's taking our 100-and-something participants that we're giving the acting class to and the control class to and running them through 3 hours or more of MRI testing where he's looking at their brains and various behavioral testing. So we should have a very good picture of what's happening by the end of this. Also, in general, there's a lack of control conditions. The people, artists are artists, and when they do investigate things, they tend to just see, let's see what happens. They don't apply controls, but the type of controls you use directly affect the information you get. And there's very few artist-researcher collaborations. It's either an art therapist who's trying to do something or a full-time scientist, and not too many get together. I was able to, I married her. So that's the way we could get together. But we do have some thoughts on future participatory art studies because we have to fill in these gaps. It really is. In fact, it's not really a gap because that implies the picture is filled in these little gaps. It's really like a blank canvas with these little spots of research here and there. So it really does require a concerted effort from researchers everywhere to work on this field because we think it's very promising, very important. So we did some preliminary work with sketching and painting by going to a number of the best art instructors we could find and saying, how many sessions would it take? Because obviously it could be different. With acting, since everybody already has the equipment, we screen for dementia. Everybody else has all the equipment. They can think, they can walk, they can talk, they can feel. So they're ready to go. But with other arts, there's sometimes a certain amount of technique involved, with sketching, obviously. So we said, what's the shortest amount of time? And we got estimates between 2 lessons a week for 6 weeks to 14 weeks. But most of them were on the low side. So we're proposing to do a sketching demonstration just like ours, and a randomly controlled trial, where they come in, get examined first, so does the control group. They get those 8 weeks of sketching, and then we examine them afterward. There are other methods, of course, and one we've started, which is not a randomly controlled trial. It's using a convenient sample, but we found there's over 800 different senior theater companies in the United States using only seniors. And we know the woman who's the sort of clearinghouse for all of that. Her name is Bonnie Vorenberg, and she agreed to cooperate. So we have a quality life survey that she distributed at a convention, and now she's sending emails to all 800 of them to get responses on this standard, reliable, valid questionnaire on quality of life to see if we can do a large-scale study, long distance, where it goes from the researcher to the umbrella organization to the individual organizations down to the actors. We'll see if it works. It's a pilot study, but we'll try it because that's one other way to do it. And the next one, a resource, very, very good. We would suggest to any researcher in the world, especially those in LA, to use this particular one. But every organization, you get it in the phone book on the internet, has some kind of Elders Share the Arts type of organization. And this one, Engage, has actually over 5,000 lessons a year they give in the arts. They have all these apartment buildings, many of them, mainly low income. In fact, a lot of them, people are living under $15,000 a year. But all of them feature teaching artists, professional teaching artists giving them. And certainly, researchers could contact Engage. Every organization would love to have research because it will help them with their fundraising, but they don't know how to do it. So it's up to us. The ball is in our court, really, to engage in research with these other companies. So we've put down the desired elements that we think researchers should use to plug the gaps, because that's a problem. When you look at the research, there is hardly anything that's consistent with any other experiment. Everybody is going his own way, no common vocabulary, no common measures. So we think there should be a standardized measures and common vocabulary. Once again, if we can get a team of researchers, say, to work with the Burbank people, they have 5,000 possibilities of investigation there. There could be one for visual arts, one for performing arts and so forth, and use a common vocabulary, common measures, and common behavioral outcomes, and consistent use of pre-post designs. That's so important. So many of the experiments, they just say, the people felt better after they did this. Well, we assume they did, but where's the documentation that would help these organizations get funding? It's almost completely lacking. Some more items here. Oh, well, it's not working. So there was one more slide, but maybe if do you have one over here that can advance it, darling, or not? No? All right. Finally came up. And we want large enough samples to be meaningful, assessment of long-term effects, more diverse populations, very important. A lot of the research was done with us middle-class white people. So I have to look at one African-American in the group when I said that, us middle-class white people. I'm sorry. Okay, but it is true. We do not have enough diverse populations. We'll be opening it for questions and answers afterward, but we were charged with keeping on time, and miraculously, we did get through before 9:30. It will take a minute, though, because our next speaker, Nina, wants to also use the clip-on mic, so we're going to change it.
All right. Good morning. I'm Nina Kraus from Northwestern University, and here's what I want to talk to you about today. So aging, the communication challenges that accompany aging, and the underlying biology. And I want to take some time to tell you then about our biological approach, because I think that it is one that can be used in terms of consistent outcomes for others in the future. That's my hope in terms of a research gap to fill. I'm going to take some time to talk about the evidence that we do have for lifelong musical experience and how it can enhance communication and biology. And I'm going to be going through data across the lifespan. But of course, the spotlight is going to be on older adults. I'll talk about some research gaps and some future directions. So, aging, communication challenges. One of the most common complaints of an older adult is difficulty hearing and noise. So cannot hear your friend's voice in a noisy restaurant. And very important. The second is memory, auditory memory, and it's absolutely crucial just in terms of your being able to understand what I'm saying now for you to remember what I just said a second ago. So it's this auditory working memory, and this is something that declines with age. And these declines, since they impede communication, lead to social isolation, depression, poor quality of life. Music as a remedy, this is the topic that I'm hoping to really get into. So here we know that musicians are very good at extracting relevant information from a complex soundscape. So when you're playing a musical instrument, you're listening, as here the three bops. They're each listening to the sound of their own instrument. And you're listening for harmony lines, for melody lines. Was that string plucked or bowed? And so we asked, well, is this ability to pull out relevant information from a complex soundscape, is this something that would transfer to hearing, speech, and noise? Because again, pulling your friend's voice out of a noisy restaurant is pulling out a relevant signal from a complex soundscape. And in fact, the data are resoundingly strong across the lifespan. Data not only from my lab, but from other labs, have really shown that if you take standardized measures of hearing, speech, and noise, so basically you play your participants' sentences, and they have to repeat back the sentences, and the background noise gets louder and louder and louder, and you can see that the musicians in red outperform non-musicians across the age, and specifically relevant to our age workshop here is this is something that we see in older adults. Memory. Music involves memory, so the memorization of sound and visual patterns, memorization of auditory and motor sequences. Just to tune an instrument, again, that auditory working memory. You play a note, you have to remember it in order to then match your instrument tuning. To improvise, you have a musical idea. If I'm going to improvise upon it, I have to remember what you just played in order to play something that responds to what you have. All of this exercise is memory. I want to give you a personal example. So this is me trying to learn a Chuck Berry lick. It's very obvious when it's Chuck that's playing. And then I have to try to hold it in my mind while I'm resolving the physical complexities. And you can get a sense of how active musical experience engages your auditory working memory. So memory. What we see, again, across the lifespan is that when we test people on standardized measures of working memory, so I give you a list of numbers, and you have to repeat the numbers back, but you have to repeat them backwards. So you have to remember them and repeat them backwards. I give you a whole list of names. Repeat back just the names of animals that start with B. So you have to remember, work on it, auditory working memory. They're standardized tests. And again, we don't see benefits with visual working memory. This very much is in the auditory domain. And older adults really show this. Okay, biology. I am a biologist by training. We know from many, many lines of evidence that aging is associated with a slowing of neural activity. Obviously, the neural activity is the currency of the nervous system, and there is decreased inhibitory mechanisms. There's broader neural tuning, longer neural recovery. These are mechanisms that underlie this neural slowing. There's increased background neural noise. How can all of this work has been done in animal models, and we need to assess this in humans. So let me tell you about our biological approach for doing this. We use something called CABR, which stands for Auditory Brainstem Responses to Complex Sounds. So using just a couple of scalp electrodes, we can capture the electrical activity as I'm talking to you now. The nerves in your brain that respond to sound are giving off electricity. We can capture that electricity, and the responses are coming from largely the midbrain, which is a very, very important area because it is a site of convergence. So here is information coming into the ear, and there are various nuclei that feed into the midbrain. Importantly, there are areas, all of our emotional areas, our executive function areas, the attention and memory, all of these areas we know neuroanatomically feed back to our auditory system, all the way out to our ears, this top-down corticofugal network. So we know that the midbrain plays a very, very critical role in auditory learning. We know this from animal models. So there are three attributes of the CABR, which is why I really do think that this is a very effective way of accessing biology that relates to communication. And I will put to you is something that currently is occurring in specialized laboratories, but really could be translated into technology that could involve a headband and an iPad. And this is a research gap where other people could use this to assess outcomes. Gadgets, somebody used the word, Emily, I think, gadgets yesterday. Anyway, it is an area that gets information from memory, attention, and the limbic system. Second, hold on. Attribute number one, experience dependent. So how you use sound in your life, the songs that you learn, the languages that you learn, your experience with sound very much influence these responses. So that's one of the ways in which it is a very good metric of biological health with respect to how we engage with sound. Second is fidelity to the signal. So we can play any sound, say here's a speech sound, da. What is interesting about this approach is that the brain wave that we get back actually physically resembles the sound wave, and so we can really have tremendous control over trying to determine, it's not some abstraction, we can really see how are elements of the sound wave transcribed by the nervous system. So we can look at important elements like pitch and timing and harmonics and really see how are these elements transcribed, how might they be changed by experience. And not only do they physically look like each other, you can take this brain wave and play it back, and it will sound like the evoking stimulus. So here's the speech sound, da. Da. Here's the brain's response to it. Here is, you'll hear musical scale, and then the brain's response to that scale. Something more ecologically significant. Okay, so beginning was Deep Purple. The second was my graduate student's brain. And importantly also, these are data that are meaningful in individuals. Attribute number 3. So you don't have to average across populations and groups, but we know that there are enormous individual differences. So I really put to you that this is very powerful technology that is currently available in laboratories and that can be, I think, translated. Okay, so communication challenges. Did you say bill or pill? We know when we look at speech sounds that speech sounds vary in terms of their complexity and their relative simplicity. And you can imagine that the fast, complex part of bill and pill is the b and p part. So the consonant is very, very complex. And what we find is that with aging, so now this is using CABR, we find that we're looking at response timing. So we're measuring the response of the neurons, and we see that as you get older, older is black, young is blue, the older responses are slower. And this is very consistent with what we know from animal models. The older people have longer, slower neural timing, but interestingly, selectively to this tricky, complex part of the stimulus. It's not as though the nervous system slows down to all sounds, but the hard, complex sounds are the ones that are inordinately affected. You've got that. Consistency. When you present a sound again and again and again, you want a stable system. You want the nervous system to be responding to a stimulus, the same stimulus, in the same and consistent manner. What we know happens with aging is that the consistency from trial to trial, so here is an older person's brain response, and you can see sample 1 and sample 2 are kind of different. There's a bit of a jitter, whereas a younger person will show very good stability from one trial to another. So neural response stability, second point. Third effect of aging is neural synchrony in the form of what we call phase locking. So the nervous system is very good at accurately responding to the sound frequencies that make up music and speech sounds with precision at the individual harmonics. And you can see that this measure of precision is very strong in the younger adults, and in the older adults, it's just gone. The response is smaller. So as you age, the responses of the nervous system to important elements of sound, the harmonics, that again really enable us to distinguish one instrument from another, one speech sound from another sound, they are just smaller. You add to that the fact that so the response to the stimulus and to key elements of the stimulus are diminished. On top of that, you have increased neural background noise that happens with aging. We've seen this in animal models, and we see this in our human data as well. So you can see that you have two things that are conspiring to make hearing complicated and compromised as we get older. So through the lens of CABR, we see an impact of aging on neural timing, how fast the neurons respond, the magnitude of the response, especially with respect to the harmonics, neural synchrony, precision, phase locking, Neural consistency, so how consistent and stable is the nervous system in responding to sound from one trial to the next. And you see this increased neural noise that happens with aging. Okay, so trying to offset these effects of aging. All right, with music, what we see, musicians are always in red and non-musicians in black. These are responses, CABRs, to speech sounds. And you can see that the musician in red is not only larger, but if you really analyze these responses carefully, you see that there is much, much greater precision in the response that you get from a nervous system of a musician. And this is true when speech sounds are presented in quiet, and when they're presented in noise. You can see that the musician's response in noise is really not even very affected by the noise, relatively to the non-musician whose response really goes to pot. We see this effect across the lifespan, and again, we really see it very strongly in older adults. So I'm reviewing the data that I showed you before in terms of neural timing. This is in response to the consonant. Remember, older adults, these are older adult non-musicians. They show later delayed neural timing compared to a young adult. If now you want to know, what about an older musician? So your older musician is like your guys. These guys they have a nervous system that is responding almost indistinguishably from the nervous system of a younger non-musician. By a musician, I mean a person who has actively engaged in playing music throughout their lives. They are playing a minimum of 20 minutes a day, 3 times a week. Neural consistency. So this, again, is something that declines with aging, the stability of the response from trial to trial. If we look at older musicians, we see that their neural response consistency is better. And again, these are very, very objective measures. When we look at this measure of precision of phase locking, and we are real signal geeks. If you want the details, we have all of this in great detail that I'm delighted to talk to anybody about. But really, anybody can look at this, and you can see that this is a more precise response in terms of how accurately are neurons responding to the sinusoids that make up any complex sound. And again, if you now compare older musicians with older non-musicians, again, the older musicians are looking about as good as the younger adults, right? The younger adult non-musicians. Look at the magnitude of the harmonics. Again, with age, we see that the harmonics strength decreases. With musical experience, it increases. So we see that music can promote improved hearing and noise ability, improved auditory working memory, and enhanced biological processing of sound. And aging seems to be the anti-music in that you have these declines in hearing and noise, auditory memory, and biological processing. And so what I've said so far is that a lifetime of making music seems to positively enhance and impact communication skills, cognitive function, and biological health. So research gaps. What about initiating or resuming musical training later in life? All of the data that really exist, most of the data, have really been on people who have been actively engaging in music throughout their lives. What about, is music unique? How does music compare to other forms of training? This was already brought up. So we have some clues from short-term training in kids and from non-music training in older adults, and I want to just review these evidence clues very briefly for you. In some studies that have contrasted music and art, kids have been randomly assigned to take music and art lessons, and then their responses to sounds have been recorded after the intervention. And what has been found is that with music lessons, the nervous system is better able to automatically discern the differences, fine-grained differences among speech sounds. And this is not something that was observed in the kids who went through the art training. And again, these investigators reported that there were enhancements in reading and in verbal IQ in the musically trained children. So, these are language skills. These are auditory-based skills, and it makes sense, perhaps, that there is a bias where music can trump the art. But again, there are so many other factors to consider. So these are just some studies. What do we know about older adults? So older adults, and we look at software-based training. So this is computer-based training. We have a study now where we're looking at a brain fitness program put out by Posit Science, where these older adults need to interact with the computer. These are auditory-based and memory-based games and exercises. And the older adults need to engage in these programs for 2 months for 40 minutes a day. So it's quite a bit, 5 days a week. And we have an active control group. And what we find is that when we look at hearing and noise, here it's plotted a little bit different than when you saw it before. You can see that after training, again, on these standardized measures of hearing and noise, the people who went through the training are able to tolerate more noise, more background noise, and still get the sentences correct. So there is an improvement in hearing and noise, a measurable improvement in hearing and noise following this computer-based training in older adults. Of course, now this isn't really a fair comparison, but if you compare musicians, and these are musicians, lifelong musicians, they're obviously still way better. If we look at auditory working memory, again, we do see gains. This is, after 2 months of this pretty intense training in older adults. So again, consistent with information that we know that the older nervous system is certainly very malleable and able to change in very positive ways. We see that there is an enhancement here. Again, the musicians are obviously better, but again, these are musicians who have played music all their lives, so they ought to be better. Again, when I showed you before, this is the timing in response to the consonants in sound. You can see that after training, there has been an improvement these are now looking at the biological measures. And these are the kinds of biological measures I would love to see in the hands of anybody doing a training study in older adults. Because you can measure very objectively, has there been a change in the way the nervous system responds to sound? I mean, again, compared to the musician, the lifelong musician, you have a long ways to go, but this is what we know so far. So through the lens of CABR, we can see the biological impact of aging. One of the very important, clear aspects of aging biologically is timing. And we see that both lifelong musicianship and short-term computer-based training has an impact, a positive impact, a speeding up of neural timing. With respect to these other neural metrics, magnitude of the harmonics, the neural synchrony, consistency, we only see these biological changes with lifelong musical experience. We have not observed them yet, or maybe we never will. We have not observed them in our computer-based programs. But, we can begin to have, and Sunil talked about mechanisms, this seems to be an underlying biological mechanism, a biological basis for the improvements that we can see in real-life skills that we care about. How good are people at hearing speech and noise? How good are people at remembering what they heard? So just summing things up here. In terms of aging effects, we know that aging does affect hearing and noise and auditory memory, and that there are biological impacts of aging, which I reviewed for you. And they seem to be these negative effects of aging on communication and on our underlying biology seem to be offset by a lifetime of musical training. They also seem to be offset, at least in part, by computer-based non-music training in older adults. When you contrast music with other forms of training, at least in kids, it would appear that music will trump art training for, again, auditory-based communication and auditory-based biological outcomes. Research gaps. So we really need to know, we don't know, what is the impact of initiating or resuming musical education later in life. And this, I think, is a very, very important gap. And to be able to then compare the outcome of music training in an older adult compared with something like a computer-based program that also, if you're going to make a choice with music versus other forms of intervention. You want to know, is music unique? How does it compare with other forms? This is something that I haven't touched upon up until now, but I just want to mention it. And that is, does the older adult brain profit from musical training early in life? So this is important in terms of education and social policy. We do know that musical training early in life actually does benefit the young adult brain. So we've just finished a study that demonstrates that. But we haven't taken that in older adults. So I don't know, I can't tell you, if you have had musical lessons as a child, will it help you when you're 65? We do know that it will help you in terms of having a more efficient brain with response to sound if you're a young adult. And importantly, how do we obtain these large-scale biological outcomes in humans? I really want to put to you that I think that the biological approach that we're using right now, we are using this in a laboratory. There are some commercially available units that people can purchase, but they're cumbersome. And really, the technology is such that this kind of technology should be translatable into, instead of having to apply electrodes, just putting on a headband, and an iPad or an iPhone ought to be able to deliver and capture the signals. And if there's a user-friendly interface, anybody in a school, in any kind of a senior center setting ought to be able to obtain these very objective biological measures. And similar to the toolbox, and again, you mentioned you want to have outcomes that are standard across different groups. And we had hoped actually to have CABR in the NIH toolbox for those who were involved with that. So initiating music training in life, we think it should work because short-term music training seems to work in kids. Short-term non-music training works in older adults. We think that, if I'm going to put my money somewhere, it's going to be on music because it seems to be a very powerful model for auditory learning, and auditory learning, especially as it relates to language. And I want to draw your attention to a paper that Ani Patel wrote. He has what he calls the opera hypothesis, and the opera hypothesis explains why he thinks that music is a particularly effective medium, an effective, actively making music seems to enhance non-music related skills. So why is music so effective at improving language skills? The O in opera stands for there's an overlap in the biology and the auditory system between the mechanisms that undergird music and speech. The P in opera stands for precision, that if you learn a musical instrument, the precision that is demanded of you is much higher than what we need for speech so that it helps you. For speech, we tolerate differences in accents and differences male, female voices. We still understand the context, the content in playing a musical instrument, more precision is demanded upon you, which he will argue will benefit the language domain. Emotion. So there has not been much emphasis on emotion. I think we need to emphasize emotion more in our studies. And in fact, even in terms of what form of training somebody might undertake, they have to like it. So somebody might like art more than music, and I would expect that they will get more benefit out of the art than the music. We know just in our daily experiences that we learn what we care about. We know from controlled animal model experiments that animals learn faster and they remember longer when their limbic system, when the emotional system in their brain has been stimulated while they are learning a task. So emotion is, and our motivation, our reward system, is a huge factor that we have to consider. And Ani Patel says, well, playing music certainly engages our emotional areas. Repetition, extensive practice, tunes the system, and the A is that you have to learn to pay attention to what are the meaningful details in sound. And I can tell you, my husband's a musician, and when I'm trying to play something, he'll come by and listen to the passage that I'm trying to execute myself, and he says, well, listen to what he's doing. You can just hear that he's pulling off on the string here. And before he said that, I was deaf to that aspect. And just through the process of playing an instrument, you learn to pay attention to what is meaningful in sound. I don't know if you need a lifetime of musical practice in order to see the kinds of fundamental, pervasive enhancements that we do see with musical training throughout the lifespan. Again, this is a gap that needs to be filled. And I would like to acknowledge my collaborators, in particular Alexandra Parbery-Clark, who was going to join us here and unfortunately couldn't at the last minute, Trent Nickel, Samira Anderson, Travis White-Swak. These have been the people who have contributed to the work that I have talked about today. And finally, I would like to encourage you, please, to visit our magical website. And I've got, let's see, somewhere. Got a bunch of cards here with a website. I encourage you to take them. And the website, I really feel a huge responsibility as a scientist to translate and to communicate our little discoveries to the general public, to parents, teachers, educators, to the many different flavors of scientists who are interested in this kind of work. So what you'll see, so just on the home page, this demonstration is a 1-minute video that illustrates our biological approach. If you want to know more about the biological approach, you can go to technologies. Each one of these topics has with it a slideshow. And the slideshow is a picture and one caption that encapsulates usually 2 years of work. So you can go through the slideshow and get an overview of what we're doing. If you want the nitty-gritty, you go to publications and get that. So I thank you very much.
Well, believe it or not, our group finished a little early. We have 15 minutes for open discussion, and that starts at 10:05, but we have 4 minutes for 10:05. So what I'd like to suggest are questions. Oh, I always have to use my mic. Okay. What I'd like to. I could probably can. What I'd like to. You want to turn it off? Help me. I know you fixed it later. So what I'd like to suggest are questions for both Tony and Helga. Yeah. No, it doesn't work at all. Thanks. I'd like to suggest now questions for Tony and Helga and Nina. Yes. See if you can break yours too.
Thank you. I have a question for Nina. I'm Jan Mayer from RTI International, and I'm very interested in what you described as music training. Was this limited to instruments that you play with your hands or blowing woodwind kinds of things, or did it also include singing?
Right. Okay, so first of all, it's very, very important to distinguish that they are actually playing a musical instrument. And musical instrument, active playing of the instrument as opposed to passive listening. So that first is just a very, very, very key point. And I like to make the analogy, you're not going to get physically fit by watching spectator sports. So it really takes the energy. Now, we have looked across a number of different musical instruments. So most of our data has been on instrumentalists. We have a study ongoing now where we're specifically looking at drummers compared to vocalists. And it will be interesting. With the vocalists, again, there are various control issues because a vocalist generally can't practice as many hours. On the other hand, their body is the instrument, so there can be something very, very powerful there. One of the things that I can tell you is that although across instrumentalists we find these very pervasive, fundamental differences in hearing, speech, and noise, in memory, and in how the nervous system responds to sound, we do have a paper which we call Specialization of the Specialized, where we find, not so surprisingly, that our nervous system response to sound is tuned to the sound of the instrument we play. So if you compare these CABR responses that you get to a piano sound in a pianist compared to someone who plays the bassoon, you will find that the bassoon player will be more responsive, their nervous system automatically. And I just cannot emphasize what we do, we are what we do. And if we spend many, many hours playing the bassoon, it gets to the point where when we can record these responses to sound, it doesn't matter if you're awake or asleep. Your nervous system just will respond to these aspects of sound that it has, through experience, learned these are meaningful elements. So I hope that answered your question. So
let's go for one more question, then we'll open it to.
Hi, I'm Michael Patterson with MindRamp and Associates, which translates science for the general public. So I'll be delighted to. I want to pick up on what you said and then ask Tony and Dr. Noice. It seems very clear that when we work, as you say, on one particular sensory strength, it'll get better. And I think that one of the mechanisms, or what Tony and Helga looked at, was the multimodal approach that happens in theater, where it seems to hit multiple different aspects. Could you speak to that? And
let me come around here, and maybe this will work. If I take it, okay. Hey, we're on, aren't we? Terrific. Yes, we are definite, very strong believers in that acting is one of the things that is truly multimodal. You're using the entire instrument, and we get these marvelous behavioral results that we've been getting for 15 years, showing that people actually increase in the necessary components of successful aging. That is, they can remember better, they can solve problems better, they're more creative. All of these are standardized behavioral tests that we take before and after. And unlike many other things, Nina mentioned that original interest is often necessary. People have to be interested in what they do. Oddly enough, acting does not seem to require that because you have no self-selection. The people come in, all they know is they're volunteering for some sort of intervention in the arts. They have no idea what it is, and yet they are randomly assigned to the theater or to some other condition. Nevertheless, they all improve. So it's very, very interesting that people who are not picking acting training nevertheless benefit from it. But we feel it's because of that multimodal thing. Because with acting, it's not just your hearing or anything else. It's it's your mind, it's your body, it's your emotions and everything else. So, yeah, we believe the multimodal aspect is really important. But I would like to, as long as I have it, ask Art a question, because we were all working for time to get three speakers in. But I would like to address very briefly. You discussed in general things that you're doing with the brain imaging. But what do you expect or hope to find from the acting study in terms of brain imaging?
Okay, thanks. Well, I'm not sure if I want to answer that question. Yeah, maybe I will. After you. I think the issue, and I think we've heard this morning, maybe I'll summarize a little bit because I am the moderator. I think the issue is the specificity of transfer and learning effects. Now, in the field of training, one of the hot topics is how near or far can I get transfer? And some of the commercial products that are available, I'm not mentioning any names, make pretty wild claims in terms of doing a specific kind of, often computer-based training and getting very, very broad transfer. I think what we saw from Nina's presentation, however, is we tend to see, and this is not new, Thorndike talked about this about 100 years ago with his theory of identical elements, that when you train on auditory skills, such as music, you tend to improve on other auditory skills, be it recognition, memory, or sensory function. And I think in your presentation you mentioned that the visual memory didn't show the same benefits as the auditory memory. So it seems to me that if we're going to come up with interventions that can help older adults function well, maintain performance, or perhaps even enhance performance, we don't need one intervention. We need a multitude of interventions that essentially exercise in a cognitive sense, perhaps also a physical sense. Nina said music is her best bet. Physical exercise is my best bet. I don't have time to tell you why that is. But I think we need a toolkit of interventions that focus on the various aspects of perception, cognition, and motor activity that show declines as a function of aging. And music evidently shows some real strong benefits in terms of the auditory modality, sensory, memory function, I bet working memory and long-term memory, and anything to do with audition. And theater focuses on different aspects of function, more of the visual, perhaps motor memory, much like music might. So I'm not sure that there is any one art form that we could consider to be, or we will ever consider to be, a panacea to negate all of the negative things that happen with aging. And I think that's why we're here, to talk about different kinds of art forms, both from the West, and I hope we address a little bit the East, because there are very important art forms from Tai Chi to yoga and so forth from the East.
If I can just add to that, I think you can still hear me on this thing, right? So I would say that a good cocktail would be exercise and music, and just to amplify a little bit about the visual effects. So in the measures that I showed you, we did not see enhancements in some of the visual tests that we did, but others, and in some of our other measures that I didn't show you, we do see visual enhancements. They are less than the auditory ones, and I really do want to put to you the fact that I think one of the reasons that music is powerful is that it does, like acting, it really does engage so many different, the motor system, the visual system, the emotional system, and so that I think as research gaps are filled, I think we will come to understand the extent to which some of these other modalities may be affected as well.
Yeah, I agree completely, and I think even in terms of the interventions, certainly we need probably an n-dimensional mapping of interventions to cognitive and perceptual processes to outcome measures, because BERs, brainstem evoked response. I was trained as a human electrophysiologist a long time ago. But I don't use BERs now because they wouldn't be appropriate for the kinds of things I measure. They're most certainly appropriate for the kinds of things you measure. But I think we need a corpus of psychosocial, behavioral, and neuroimaging, from electrophysiology to near-infrared spectroscopy to fMRI activity, again, to get a rich picture of the benefits and the lack of benefits under some conditions. I want to open this to discussion. We have a few minutes left. Yes? You're right there, red shirt. Oh, okay.
Otherwise, I'll run around with this thing.
Hi, my name is Ashley White. I work at the National Science Foundation, but I'm here mainly because I teach a course at the University of Maryland on science and music. So I wanted to take the first question asked a little further, and I think this applies to both types of studies that were discussed. But when we define what a musical intervention is, we can say, is it singing or is it instrumental? But even, we asked about, is it a wind instrument or a string instrument or the drums? But in addition, if we're going as far as talking about visual aspects as well, are we talking about someone who is usually sight reading music? Is it music they already know? Are they doing ensemble playing or solo playing? Are they improvising, or are they playing classical music that is arguably more complex than rock music? So how can we possibly kind of work around all of these different factors?
Yeah, so these are such important points. And, so if you learn music Suzuki style as a language compared to reading notes, certainly the data, some of the data that are available, again, just as the question that came up before, is that the active engagement of music, irrespective of how you come to it, is in the end the final common denominator of what matters most. But there is a tremendous amount of knowledge gaps in terms of fine-tuning of what strategies might work best at what ages, what dosages. I want to talk about education for a minute because so much of the work on the effects of musical experience on the nervous system has been done on people who are privileged enough to be able to afford private instruction. So what about music education delivered in schools? We're now involved in 2 gang reduction site studies, one in the Chicago area, one in LA. And even those 2 studies where we're looking at the outcomes of music education delivered in schools, the approaches are different. So in the Chicago public schools, the music intervention, the music training is done by teachers, by educators who know music. And in LA, this is the Harmony Project. In LA, the music is taught by musicians. So these are very, very important research gaps, and thank you for raising them.
If you don't mind, I have a question for each research team. Following up on your question to Nina, for much of your presentation, you did talk about musicians, but there was earlier on in your presentation, you spoke about musicians who play, who are collaborative, or either in a combo or a symphony or whatnot. There was that effect of having to listen to one another that had the benefits, and I'm wondering, have you found a difference, and maybe your N isn't large enough, have you found a difference between those people who play regularly and alone versus those who are combo people?
Yeah, you guys are great at identifying research gaps. I mean, to me, it is a huge, big deal to, I think, have come to the point of finding that there really are these pervasive effects of musical experience in people who are both soloists and who play with ensembles. I am certain that there are some differences that I'm so excited to learn about with future work.
And
in terms of theater, yes, the absolute essential of theater, as we demonstrated, is you must take in, give out, take in, give out. So you are always in theater working with others. It's always receiving, giving. In fact, a good actor actually brings out the performance in the other actor. It's what I do that makes you do that. What you do makes me do that. So that cooperation is essential in any theatrical endeavor, yes.
And does a great director like yourself, something I really wanted to commend both you and Helga on is your wait list. There are so many community-based studies that get proposed and actually enacted that do not bring the intervention to all the potential participants. And so I really want to applaud and thank you both for doing that.
Thank you very much.
How about, we're getting close, how about one more?
Okay, I'm Elizabeth Shea. I'm here from Indiana University. And this question, it's more a comment than anything, but I think it goes to Nina's comments about music and all the wonderful things it can do, and Art's comments about physical activity and theater from Tony. And I just want to point out that there is a wonderful art form that actually brings all these together. It's called dance. And I was wondering, and I'm a dancer, but I'm interested in research of this nature in terms of dance interventions. And we are about to launch a Dance for Parkinson's intervention at IU, which we're very excited about. But in terms of gap research, perhaps this is a gap.
Well,
Happily, there's a lot of research on it. In fact, in the paper that everybody will have access to, that each one of the speakers is preparing, we address that. There's all sorts of wonderful studies on dance, and both on dance interventions, but about the benefits of lifelong dancing. They're incredible. People who have danced for many, many, many years, ballroom dancing, where they have to really learn the steps as well as the quality of movement and so forth, are so much healthier, it's almost off the charts. They did it with people who've danced at least 16 and a half years of ballroom dancing on the average. The results are just incredible compared to non-dancers.
Just a follow-up comment. I think these data are very interesting, but they are not causal data. They're cross-sectional data.
Right.
And I think we really need to do the longitudinal studies. Thanks to Molly Wagster and the National Institute on Aging, we are doing such a study now, contrasting walking with ballroom dancing, with toning, stretching, and strengthening, with a multitude of behavioral, psychosocial, and neuroimaging measures that we've used in the past with our walking interventions. So I think these contrasts are important. I think dance is great because it's multimodal, and hard because it's multimodal if you want to get at mechanism. And that's true for theater too, and it's probably true for music. I think a lot of the art forms are clearly multimodal. So when we talk about mechanism, it's often tough to come up with an answer there. And I'm a born-again non-reductionist because I sit on NIH panels and NSF panels like many of us do. But I truly see the value of interventions and art forms and other kinds of activities that we can't break up into little pieces. And indeed, if we break them up into little pieces, we might lose the art form. But it is tough to get at mechanism this way. I think the data that Nina presented and her career is a nice demonstration that you can get at mechanism and be led by theory, whether it's theory from biology or psychology or combination, to examine some of the underlying aspects of audition and how they might change and how music might be important to them.
If I can just add, we included in our review one study that has been done in Germany and with Parkinson's disease patient, and after one session, they showed remarkable improvement in terms of gait and other things. And I'll be glad to give you the website because they have the whole dance program, their whole hour that they're doing on the web, and it's just an incredible program.